You know X, Y, and Z axis, right? You know 3 dimensions, right? So let's just say the cost. So the cost is going to be the dependent variable. And then the what's it called? The weight and the bias are going to be, oh, okay. So the weight and the bias are going to be independent variables. But then the problem with doing a 3D graph is that we cannot like it's hard to simulate a 3D graph. So what we can do is create a contour plot. Have you heard of a contour plot? Oh, okay. So let me introduce that to you. So a contour plot is technically, let me find one contour. Okay, so technically you're gonna represent, okay, yeah, maybe like this one. So what you're gonna do is you're gonna oh my God. Actually, I'll just do this one. Okay, so what you're gonna do is you're gonna represent, so you have your X and Y, which are your your independent variables. And then these lines, so every time you cross a line, like let's say your model, like because you're, so let's say the X is the weight and then the Y is the bias. So let's say you're at 3, 4. I mean no 3, 5. So if you're in 3, 5 and anywhere in this like oval shaped place, then your cost is going to be like in a certain interval. So your error is going to be in a certain interval. If you go out further, usually that means your cost is increasing. So your error is going up. So as you go farther and farther out, your error goes higher and higher. But then over here towards the middle, your cost is low. So what we're going to do is we're going to plot a contour plot of our weight and our bias. So we're going to have the x-axis to be like the possible weight values, and then the y-axis is going to be the possible, yeah. So it's going to be the possible, what's it called? Possible bias values. So over here, the code. So to create like a list of possible weight and bias values, we're going to use mp.arange. Have you heard of it? mp.arange? Okay, so mp.arange is mainly like, you know the Python range function, right? So your first parameter, so your first argument to the range function is going to be your start and then stop and then how much you step. Okay, so the reason why we can't use Python's range is because the step, it doesn't take in decimal values, and we're gonna need decimal values for this one. So that's why we're using mp.arange. So what happens is that we start at 0. Yeah, but then it's a range function. The difference is because the step value has to, the step value for Python has to be in integer. It can't deal with decimal values. So yeah. So we're gonna start at 0. So remember that that our weight value wants to be 10. So we're gonna have like the middle of the plot to be like 10. So we're gonna start at 0 and we're gonna go to 24 and then we're gonna step 0.1. And then your possible bias values, remember that your bias has to be, what's it called, 20. So we're gonna set like the middle to be close to 20, I guess. Yeah, close to 20. So we're gonna start at -20 to 70 and then we're gonna step 1. So to create a contour plot, we need to get the cost with these. So we need to take the cost. We need to get the cost using our possible we need to create a combination of weights and biases to figure out their costs. So what we do is we create a placeholder of cost values using mp.empty. So it just creates an empty array, but then your shape, which is the number of rows by the number of columns, it's going to be, so there's gonna be so the number of possible weight values we get is gonna be how many rows we have, and then the number of columns is gonna be the number of possible bias values we will have. So what we do is we create a combination by using a for loop. So for every weight value in our in the range of how many like weight values we have and the bias values, we're gonna set the model.weights. So remember how weights are a matrix, but then right now, since we only have one weight and one bias, so we can index 0, 0, which is the only weight 0, 0, because that's the first weight and the first weight in the first row and the first weight in the first column. And that's, we're gonna set that equal to our first possible weight value. And then we're gonna set the bias value to be that as well. And then we're gonna forward the model to get the predictions at these possible bias and weight values. And then we're gonna fill up this NumPy array using the indexing for row and column. And we're gonna take the float value of the cost we get, which is the error we get. And then to plot a contour plot, what we do is we start with a figure again. So we plot a figure. Then levels are like so what values do we make, what values do we like? So like, let's say we have 0 0.5, 0, no, let's say the possible cost values are going to be like 10, 20, 30, 40. So 10 is going to be like this outer ring, this inner ring, and then 20 is going to be this ring. So this ring represents like, so if you're at 3, 7, if your weight is at, yeah, okay. And then so since if you're at like a weight value of 3 and a bias value of 7, it's going to be 20, and then outer ring is going to be 30 and 40. So levels is how many, like what cost values do we want to create a line for. So we're going to start with a list of the mp.arrange. So we're going to start at 20, and then we're going to increase all the way to 100 with a step of 40. So 20, 60, 20, and 60, because stop does not include the 100. And then we're going to extend this list using another list that starts from 100 and goes to 400 with a what's it called, with a step of 100. So it's going to be 100, 200, 300, and then it doesn't include 400. And then over here we're going to extend again 400, and then we're going to go all the way to 6,000, but we're going to step 200. So it's going to be 400, 600, 400, 600, 800. Yeah, you get the idea. And then to plot, we're just going to plot our possible bias weight, and the cost, which is the possible biases, is going to be on the x-axis, and then the possible weights is going to be on the y-axis. It's because the x-axis is usually the columns axis for cost, and then we're going to set the levels equal to that. And then we're also going to plot our history as we're updating. So we're going to use a color of red, and then we're going to label, and then save it. So this is what we get. So you see how the weight is jumping up and down, and then the bias is slowly inching its way to 20. The weight is jumping up and down to get to 10. And I'll expand on like what we can analyze from this contour plot in the next meeting. So yeah, I'll expand on it because there's a lot to explain for this. So that's